Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev where you can find the progress that we've made. If you're interested in the project, you can find the Discord server. You can find all the code that has been decompiled so far. And as always, please like, subscribe, comment. I'm streaming live on Twitch Monday through Thursday, noon Pacific time. Come join chat and have fun while we figure out the details of the different parts of the game we're working on. So we've been working on the Sword Familiar, and we're going to keep working on that today. I don't know if I'm going to keep working on the function that I have been working on the past couple days. While there is more to do, I think most of the interesting stuff has been done, and the rest is just kind of tedious and the kind of thing you need a stiff drink and a quiet night to get through. I will go through some of the things that I did discover last night as I was working through this that I hadn't come across on the stream yet, and there's probably a few more things in here that are similar. The first being a lot of these are S vectors, and let me actually pull up the docs. I was able to finally find where in the SDK docs all of this information can be found. And that's in the inline programming reference. And this is actually convenient because it is the closest thing that we'll get to a function signature for the PSP version of the game. So this is the inline programming reference for the PlayStation 1. Things like GTE, STDP. Now we know that STDP stands for Store Depth Queuing P. What is P? P is the parameter that you're passing in. And we know now that that parameter is a pointer to a 32-bit value that gets sent to the geometry transform engine coprocessor. Likewise, set flag was not, or store flag was not one of the macros that we had previously had imported into the project. So that's there now. And so I spent a little time in those header files describing what those macros did. But this is a reasonably terse document that doesn't go into a lot of details. We can find examples where all of these functions are being used, but the comments, I think, are not terribly helpful. I haven't been through and done a thorough reading of this document. I don't know how much it explains the hardware or if it's just explaining the macros. But it was nice to find this. And again, so this is, if you come across these documents in archive.org or elsewhere, this is inline ref .pdf. Good evening, Dig Down Deep. Good to have you on. So what I want to do, we're still pretty much in the same place as last week, where we have 5 functions. We're close-ish on several of those functions. I want to go through and just take some inventory of what functions are remaining and what the progress is. I know that I had mentioned on Monday that Eugene had taken one of the functions that we worked on, and it looks like he had gotten it relatively close. We could see if we can finish that off. But there may be some other work. I think there may be 1 or 2 that haven't even been started yet. So I'm going to go over to the terminal and just look for any of the include ASM functions that are remaining in the sword familiar C file. I'm going to make a to-do list for myself. And we'll see where those are. So let's look at each of these, and I'll make a column for PlayStation and a column for PSP to see where each of these are. And I'm going to go just search in decomp.me and see where these are. So it looks like, oh, this is this is the one that we've been working on. This is our function from the last couple days that is full of all of these GTE macros and inline assembly. 6BC is, I think this is the one that maybe Eugene was working on and had gotten close on. Yep. We're at 98% on that one. Okay, so 8C8 has not been started yet. .674 has not been started yet. And then the last one is F28, which looks like that one's at about 98% as well. So this one had some funny addressing. I have figured out the addresses of some more things, or like the types that may or may not be helpful. I don't think it's any of these though, unfortunately. It's hard when functions use global variables for their own state, but that state isn't shared across several functions. So unfortunately, that is what it is. So I think I'm going to look at 8C8 or 674 and see if there's anything we can figure out there. So let's go back here. We'll add that as well. And let's open sword.c, where all of the functions specifically related to the sword familiar are currently written. Go to the right directory. And so I want to see where these two remaining functions are. So this is part of the main description. What I'm mostly seeing is what is the entry point here? And the entry point for this is the game engine itself, and not other things in this file. So we don't have necessarily the context that I would like. Let's open that sword to do again, and then 6674 is the other one. And that's the same thing. So we don't have necessarily a lot of context here either. I'm going to start with the 6674 and see what is there. I'm kind of going back and forth between working on functions a little bit and working on importing data a little bit, and kind of working both sides to try to make each easier. Close this here. So this is one of the longer functions, but it's not terribly long. So let's see how this goes. I'm going to copy this, and we'll start a new scratch in Decomp. We're working on the PlayStation version. I'm going to do some things that I don't normally do, thinking ahead. Because this is a function that is being accessed from outside of this overlay, what the signature typically is for these is a void with an entity as an argument. So I'm going to make that assumption beforehand, and this will give the initial decomp by M2C a head start on some of the naming. I think that's all that's necessary. This is pulling from, this is the PSP version of my context. I'm going to go grab the PlayStation version because that's going to be a better starting point. Grab this one. And we'll see what there is to see. So a little bit of logic to untangle. This looks pretty similar to other functions in the Sword Familiar, where we're going to get this fairly simple set of blocks that GCC is optimizing out into common code. And then we're also going to see something like this, where this really should be happening outside of this switch. And this block 40 being the default case and having every other case effectively redirect to that at the end. That tells me that it should be after the switch, and basically everything should be breaking to after the switch. And then the cases where we are breaking, those should just be returns. So we kind of got to flip things around a little bit from where it currently is. And then there is one unknown variable so far. We have some function signatures to clean up. This var a2, if we find block 36, this is going to be the third argument here. So let's find create event entity, and having that function signature will give us a slightly better decompile. So here's that function signature. Throw that into the context. And we can remove it from here. Wrong one. This one here. I want to double check all entities valid. Make sure that that is like it says. That looks like it should be returning a sine 32. And it is. And then is movement allowed was the last one. I'm not going to flip back. And that looks like it takes a sine 32 as well. All right, so we have those signatures. Let's get a new decomp that should fill in that type for that var a2, whatever that was. Here it is. And it chose the right thing. So hopefully this is compiling. It is. Okay, so 64%, not bad. If you're new to Decompilation or haven't watched the stream before, what we're trying to do is match the assembly that's generated by our C code to this target assembly that was found on the game disk. So going from top to bottom, there are a bunch of globals that some of these we can get rid of. Some of them will probably need to be fixed. They may or may not have the right types. I'm going to ignore them for the moment and just kind of run down here and try to get rid of as many of the local variables to this function as possible. We've seen that the style of this code is usually pretty variable light. So I just, as I'm going through, just need to be careful to not delete things before I've gotten through all of their dependencies. And during this phase, I'm going to kind of be keeping an eye on, I want to get this to 100%. I'm going to be keeping my eye on that, but I'm not overly concerned with it right now unless it changes dramatically. In this case, that's var A1. I'm going to make an assumption that this is actually going to be an assignment of this global. This assignment might be backwards, but that the var A1 is not necessary. And typically when we're looking at the facing left field of the player entity, it's not an explicit check against a value, but just a truthiness check. And over here we see that branch not equal to 0 versus branch equal to 0. This needs to be negated, and then these values flipped. These almost look like Soten floating, or sorry, fixed point values. So it's likely that these are a velocity. Yes, most likely a velocity. So we're taking the play. This is the player. The player's current position, adding a velocity, and coming up with a translated point. Continuing on, there are macros for doing squares. I haven't traditionally used them. I have noticed that some of the other code coming in related to familiars is using them, and so maybe it would be a good idea for me to switch that over. But I don't know. This shift by 10 is taking a PlayStation formatted floating point and grabbing the integer portion of that. Oh no, 10 wouldn't be. Sorry, this is 16. This is taking a Soten, and we saw that here, a Soten formatted fixed point value and shifting it by 16, which is the kind of the same thing. That's the integer value of that. Why Soten didn't use the native PlayStation version, I think it has to do with alignment. It's much easier to grab the integer portion of a 32-bit value if it's split at a 8-bit boundary. I'm going to delete these and then use the compiler to help me find where I need to fix these. These are global symbols, and we just need the access to those addresses. This is a relatively for this code, having this much. I'm going to rewrite this a different way. So temp v1, we can reorder this. And I'm going to do what the kids are doing nowadays. We don't need temp v0 until down here. This temp low, we'll worry about that later. It's being used here. This is going to be an inlined square of this. Basically, we have the Pythagorean theorem here. So we're just figuring out the distance between 2 points. Sorry, distance given two sides of a triangle. All right, so then this is our last part of this, just making sure that I have all the other temp v1s. And this looks pretty close to what I would expect here. It is possible that this 624 is a vector of XYZ values. What's a little different about this from other this should be in this order. From other areas where these calcs are being done is the distance isn't being calculated for all three x, y, and z. It's just being calculated for y and z. Why would that be? I don't know. But maybe we'll look at that a little bit. Here we have a superfluous assignment to var v1. When velocity x is being set in here, we expect velocity y to follow suit. In general, all of this is usually organized the same way. This we'd say greater than 16, so greater or equal to 17. I'm noticing that there is some missing or out of order work here. I'll come back to that after I go through this. So we have an offset into the sort familiars entity extension that may not have a value yet, or it could just be that illegal is the first one in the list and it has a match. So we just need to go through and figure out what that should really be. Some of this down here, I may reference some of the other functions. This is a relatively common pattern, and I've untangled it several times. I don't know if I want to do it one more time. Let's get down to the switch, which I think is going to be the first area that's should be considered. There's a few things down here I think I could do. they're not going to help significantly, but they'll be closer to right. All right. So with our switch, now we're going to have to untangle some of these go-tos. And I'm going to start with the easy ones, and then we'll get to the harder ones. So block 38 is just incrementing the step and then jumping to block 40. There is this wacky thing here. We'll get to that in a minute, where the block is. This one is too. It's in the middle of a condition, which is kind of funny, but C allows it, and it doesn't really affect the program flow. It just looks funny and is not something that we typically see. So these are going to be can be written as self step plus plus, and then go to block 40, and we'll deal with block 40, like I said, later. And we can replace all of the, in this case, we don't need to go to, because we're going to go to down here. And I think that's all of the block 38, so that was easy. Let's find block 36. So block 36 builds on that. We're going to create the event entity increment and then jump to block 40. And that just exists here. So we don't need that closing bracket. And so that gives us the ability to get rid of that other block. So now the last part is going to be this block 40, refactoring that. The first thing I'm going to do is look for all the breaks, because breaking here is getting us to the end of the switch, and then it's going to return. And we're going to move this block 40 code to the end of the switch. So anything that's currently returning can't run that. So we can return directly here. And it may actually be more reasonable to just return at the end of this condition, because this is going to be the only case where the return happens, and then this is going to break. And so this return is no longer necessary. And this entire else block is not necessary. And I think that does everything to set us up to safely move this block 40 now. I am going to put a go to block 40 here as a placeholder, and that's just for me to keep track of what's going on later. So the default case we don't need, the block 40 we don't need, and the return we don't need. So now we have all these block 40s, and the block 40s are just going to turn into breaks. And that's the reason I kept it there, so I could find it easy and make sure that I didn't miss anything. Looks like I did miss one. It looks like, let's think about this. I think this can turn into an else if, and we can get rid of this. I think that works. And that gets us to about 76, which is not too bad. It's the first time I'm saving. Too much work to save now. This may be a ternary. Let's go down and see what we have. Actually, let's start at the top and see how many of these we can clean up now. So what I want to see is if the last assignment to this 8626 global was temp A02, then I can replace it here. And then the only cases that we have of temp A0 are negating this, and that allows us to get rid of that value, and likewise temp A2. I did say that I would not untangle this now, so I'll come back to these because there is other functions that have very similar structure, and we could just copy those instead of working through it again. So this A2 is being used. Temp low is no longer being used. These temp v0s, it looks like most of those can go away as well. So temp v0 underscore 3 is going to be this. We see this here again. We're calculating a distance, same as above, with this same set of globals. Likely this is a vector. And as I get rid of these, again, this isn't going to be doing much to get better code coverage, but it is. I just want to make sure I got the right ones. Yeah. It's going to make it easier for cleaning up later. Oh, I missed one along the way. Let me just make sure that is what I thought it is. I always have to be careful about not deleting temporary variables until I know what they are and have made all the replacements. All of these V1s are gone. That's nice. So I can't replace var A1 with the global 62C. And the reason is because that it's being assigned and that assignment isn't propagating back to 2C. Hey, Mozilla, good to have you. Doing well, doing well. Working on, I think, one of the easier functions, hopefully. So I think this var A1 underscore 2, it looks like this is going to be, oh, I thought it might have been Z, but it looks like X. Is this 1C? No, it's not. 624. See if 624 is being used elsewhere. So it looks like X. So I think that it's safe to call that X. And that variable will stick around. And likewise, this 2.8 is probably Y. And so we'll keep that one around as well, and we'll call it Y. It looks like this is, let's see what I think that's params, a set of params that are passed to create event entity. Let me go over and look and see what that's used for. Yeah, params. So let's name that one params. So this looks like it also is X. I'll come back to that in a second. I think that this is doing some scaling. I think it's a division, if I remember correctly. We have this code elsewhere though, so I'll come back to it and we can look at this. So this is one of the things GCC does when you're doing integer division or multiplication, and it needs to worry about overflows or underflows. So I'll come back to that one. Sorry, wrong window. It was this var v0 that I was saying. So when we see things like this, where there's negation and shifts and other things like that, there's may or may not be either a mod, division, multiplication, something like that. So we can get rid of that one as well. And then we have this last one. Okay, so I think that is all of the straightforward cleanup. Let me find... I'm going to grab this get target position with distance buffer function, and we'll find one of the other functions that has been decompiled already and uses that. So we're going to see a relatively similar pattern, or should see a similar pattern with doing a tangent, assigning x values, etc., etc. Those aren't the ones that I'm thinking of. Oh, these are just absolute values and then shifts. So I'm going to keep this up. This is from update servant default. But I think this will serve as a relatively good guide for how the rest of this will look. So we need to figure out what offset we're dealing with here. I think that this is going to be unknown 88, possibly unknown 86. So let's look at this. So we have unsigned 16, we're 4 in, so that's going to be 8 bytes in to the entity extension. And we can go look at context and find the sort familiar entity extension and see what is 8 bytes in. So 2, 4, 6, 8. Unknown 84 is defined elsewhere, so there should be a unknown 84 there. And the other way we can determine what that offset is by looking at the generated source and seeing what it is. It looks like actually unknown 88 is what I'm looking for. And what's interesting about the way that this is written, actually it might not be unknown 88. I think it is unknown 84. So this var a0 is only used as the first argument of this function, and it's not actually a real variable. This function is called two different ways, either with the static hex 400 or with the sort familiar 84 field. And so we replace this first argument with a reference to that field, and then the rest of the arguments, or in this case, var a0 is the static hex 400. How are things going with you, Mozilla? Anything interesting come up lately? And we can kind of go through this and see if that's compiling to what we expect. And it looks like it is. So then down here, this is where we're going to deal with the absolute value. When I'm in Scratch, I use built-in absolute value. And then all of this falls into place. Oh, bummer. That's no fun. Is that something frequent? Or is it just one-offs every now and then? This X ultimately is getting reassigned down here. I'm trying to see if this is going to be necessary otherwise. Things have gotten cold up here, and it's not something that we went from like very nice weather to extremely cold. Not extremely cold. It's still above freezing. I'm just a wuss. In a relatively short period. All right, so this is a little different than elsewhere. No, we're already doing the... Yeah. Yeah, pressure changes and things like that. No fun. I always reach for the pseudoephedrine when bad sinus time comes. Just try to get through it as quickly as I can. All right, so I'm making a little bit of a mess out of this, but I think I should be able to clear it up. I might have to go back to the decomp. So the ordering of these is a little strange. This 7C should have another field associated with it. I'll get to that in a bit, though. This didn't work out like I had hoped. I'm going to move past this, though, and kind of continue on. I think I missed a possible switch here, or a condition. But I'm going to keep going and try to get there. All right, that all fell into place. That's good. Get rid of all these extra. All these extra casts. All right, so then what we're left with here is this looks like an addressing issue. So FBC was determined by the decompiler to be a unsigned 8. I think it's going to be either an array or a struct, and we need some way to calculate the offset into that. And the reason I think that is because of how these instructions are. When we're adding an address, and then we're taking an offset into that address, and typically that means it's a array or a struct. In this case, the compiler can see that it's the 0th element, and that looks like it is hard-coded. And that should mean oh, that's interesting. The cast is interesting. That should mean that it can oh, what? Okay, so sorry, lost my train of thought. It could compute this offset and bake it in. I don't know why it doesn't. It doesn't go to the address directly, but fortunately, it's a hint as to what the type is. So we kind of have a weird thing here where we're subtracting 1 and then saying, is it less than 2? And usually what that means is it, there's two conditions happening here. Is it greater than 0 and less than 3, I think it would be. Let's try that. And it will end up compiling to the same thing, but the cast won't be necessary. Not quite. I'll get it. Maybe greater than 1. Greater or equal to 1? Greater than 1? Come on, we can do it. Greater than 1 and less than 2? All right, let's go back to what it was. Let me think. Let me see if I can make a truth table in my head. So if we subtract 1 and then we're less than 2, so that means that we're actually less than 3 or greater than 1. Is that right? Maybe? Yeah, that's going to be equal to 2. Oh, I'll come back. I always fail at those. Actually, looking at the PSP version, hey, Love-Kun. Yes, looking at the sword familiar. This is a function I just started this morning. And I'm trying to get through it relatively quickly. It's not too challenging of a function, but there's always things. All right, so we have some a register swap somewhere along the way that may or may not be related to whether or not these checks are truthy checks are actually 0 checks. I've mentioned before that my theory is that if it sounds like a Boolean, the check probably is not against 0, but just truthiness or not. It doesn't affect our registers. Well, you're in the right place. And really, I mean, some of the stuff, so Mozilla's in the chat, and other people from the randomizer and speedrunning communities have really done a lot before there's code. Nate the Great shows up quite a bit and has lots of videos on that as well. So I'm not sure what's causing these the self argument to be pushed into S1, but I will come back to that. Sort stats we should fix. Sort stats is a struct. The decompiler didn't know what it was, it just knew that there was a symbol named that. And so it just assigned it or ascribed to it a 32-bit value, gave it assign 32-bit type. We should look here, and actually let's go back to the terminal and see how that's defined. So that's going to be a familiar stats. And we'll throw that in the context. And then can update this. And what is the first field of familiar stats? Level. I think we've seen this before. My guess is that this is going to end up being level 70. We're looking at 32, hex 32. Level 50. Oh, this is different. So there's other cases where we've seen level 70 result in different behavior. But now we have level 50 as well. So it'd be good to keep track of that and try to figure out what's happening at sword level 50. So a bunch of register issues that likely aren't related to any of this code. On 126, there is a jump to 4cc that is missing, and so our branch is quite a bit different. That is a... Oh no, the branch isn't different. Where is this immediate DD coming from? Oh, that's our... Oh. So what's happening here, and I missed this, there's not actually a separate variable. We're either calling the function one way or another. Let me pull up the Soten wiki and find the sword familiar. And I haven't actually spent a lot of time reading. We've spent a lot of time decompiling sword familiar, but not a lot of time reading about the sword familiar. All right, so what does the wiki tell us about the Soten version? Once reaching level 50, the sword familiar will disappear from the screen and can be equipped as a weapon. Oh, that's interesting. Or reactivated. And changes appearance. Oh, thank you, Level Kun. Level 60 deals damage. I don't think we've come across that code yet. At level 70, it changes its method of attack, and we have seen that. We came across that earlier. And then the level 90 change, I don't know if we came across that earlier. It wasn't... Either I didn't know the data types at the time or something else, and don't remember that specifically, but we could find that as well and see if we've decompiled that. All right, so this is that transition then to level 50. And so I wonder if this is I'm not sure. We can come back and figure that out. All right, so there's still some things to resolve. I think it's mostly in that a little bit at top, and then mostly down at the bottom. All right, so let's figure out where this is. So this is the wrong direction. Nope. I'm not sure why it wants these flipped in a particular way, but it's not allowing me to change the BNEZ versus BEQZ, branch equal to 0 versus branch not equal to 0. GCC is not allowing me to just flip that condition. So there may be something else going on here where either this value isn't being assigned like I think it is and being assigned to a variable or something else. While I'm up here, I'm going to see if I have gotten rid of all these other variables. It looks like it. So this ordering, I might switch over to the PSP version if I can find it and see what's happening there. One hint is, and so let's try a ternary here. I don't think that there's a separate variable. I wrote it the way that I did because it seemed more similar to other stuff that has been written, but that looks like what it was. All right, so that's fixed. Down on line 57, just below 57. This ordering is a little strange. What I would expect here is that these values would be, oh, yeah, okay. It just looks like it's out of order. Maybe this one is coming much later. Sometimes the out of order calculations are trickier than they should be. That's right. Yeah. So as we're decompiling, we have this target assembly that has come from, in this case, the PlayStation binary, from the Sword Familiar overlay. And what we want to do is exactly what you said, rewrite C code that's going to produce the same assembly so that we can recompile it back to the same overlay file. Let me save this. I think for untangling this logic, I'm going to switch over to the PSP version. So if you haven't seen how we work on this in the past, I usually start off with the PlayStation version, and that's the primary target right now of the decompilation project, is to get matches for the PlayStation version, but we're also looking at the PSP version, and to a lesser extent, Saturn and Xbox and other things like that, where we have uniquely compiled versions of the game using different tool chains, and the different tool chains give us different hints as to what that code might have looked like, or how we can reproduce the same thing. And fortunately, most of the code between the different versions of the game is the same. So we can see, in this case, what GCC is going to produce, what MetroWorks is going to produce for the PSP. To find the PSP version, I like to find a unique value, usually some unique immediate value. I'm going to go with these params for the entities. Yeah, and actually for the stuff that we were working on earlier in the week, there are several inline assembly macros that are used for the PlayStation 1 that were part of the PlayStation 1 SDK. When they retargeted for PSP, and to a certain extent how they retargeted for like the Requiem collection and other things like that, is they wrote a custom translation layer shim for the PS1 SDK for the PSP to compile to native PSP, as opposed to running just the PS1 version of the game. And so we see where things were inline assembly before they become function calls on the PSP, and that also works to give us more hints. So I'm going to look for this 4FF in the PSP assembly and see if that doesn't give too many hints. Oh, it doesn't give any at all. Great. So let's find another value that looks unique. The entity ID D1, maybe. That's a relatively small number, though, and small numbers make me nervous. The 1C and 1.8, possibly. Yeah, let's try the D1 and see if that works. So a bunch of hits here, more than I'd like. So going back over here, how many times does OXD1 appear? 2. So are there any files that have 2? So I'm going to change my grep to just... No, I can't do that. Let's see. A couple of them, so 7DB0, 7B8A0. I'm going to work from the bottom, and so the PlayStation version has a jump table. I don't know that this version will. And I don't think I have the symbols for like facing left and other things like that. This one is calling cosine, which we don't have in ours. Oh no, we do. Never mind. It does have this 1.8 and 1C. So let's try that. So then back in, oops, I was looking over here. This is a possible candidate. So let's make a new scratch in decomp.me, this time for the PlayStation Portable. And provide what the likely function signature is, and let's see what we come up with. Yeah, and some of that, how it handles those things. So we have, let's see if that looks the same. That looks pretty similar. So let's see what happens. Let me get the context. I think some of that sound difference and other things like that is, yeah, that was, oh good, I picked the right one first time. Is because they've re-implemented a bunch of the PS1 hardware in software. All right, so oh, this is somewhat interesting. And I'm going to get the order wrong for the moves. This assembly syntax often throws me off. This may, I think I got rid of that function signature. Let me see what M2C is going to tell me the function signature is. It looks like almost that it is returning self, but no, it doesn't think it is. Okay. So when we're looking at the PSP version, we can't rely on symbol names. So we're mostly just looking at instructions and what those might look like. It looks like I was wrong about this altogether. And how this reads to me is that we're going to be assigning negative, this negative 18 value. So this is a SOTN version of a fixed point value. And then if the player is facing left, then we're going to assign this again. Was that matching any closer? There's something else happening earlier that I'm missing. Oh, yeah, I've seen this before as well. So this assignment happens, and then it's being masked afterwards. Why, I don't know, but that's how they did it. Now I have this wrong again. I'm going to try it this way and see if the compiler likes me. No, so let's go back to the ternary. I'm going to grab this from the PlayStation version. So at this point, what I'll do is just kind of flip back and forth between the two versions of the game. And as instructions are matching or failing to match, then I can somewhat tell if we're getting closer or further the way the PSP was compiled for overlays was without optimization, so we get a lot of additional information that we wouldn't have gotten otherwise. So this is a shift by 4, and this is I've seen this happen before, but it's taking this value and then shifting it by 4 again, and GCC will see the double shift and convert it into a shift by 8. MetroWorks without optimization does not. So a lot of these things will compile to the same thing. So now on line 65. Now we can see the ordering a little more clearly here. So there's this assignment here. What we should be seeing is a sign extension. SEH is sign extend half word, so take a 16-bit value, assign 16-bit value, and convert it into a 32-bit value. But what's happening instead is it's being masked. And so what I think is this has been marked as a 16, unsigned 16, but maybe should be signed. Yeah. So this probably came from other code that has already been decompiled. So I have to go find this variable, and excuse me, I have to update it on the PlayStation side as well. But then go back and see if it affects any other code that has been decompiled already. That was the right one. So this is being used a couple places, and I think this has been fixed on this side, and my context is just wrong in decomp.me. This is an it was chosen to be an entity search, whether or not it's that field or that struct is unclear. Roman and I had some conversation about that earlier in the stream. I think it was just the right shape. So let's look at what that struct looks like. It's a pair of unsigned 16s. In this case, though, we're doing a 32-bit assignment. So it's possible that these are XY, and there's several instances where XY values are oh no, this is the first part of it. So what could we do? We could see if that works as a signed value. I'm going to keep it as signed 16 and worry about it when it comes time to move this code back in. Famous last words, but I think it'll work out. All right, so a bunch of missing stuff on 72. Oh, this, yeah, I thought I had missed a condition down here. So we're looking at this F0. Our F0 is, oh, F0. Any F0 fans in chat? I have the GameCube version of F0, and I've never played it, and I should. I had a lot of fun playing it for Super Nintendo. That is a series that Nintendo should bring back. So that's our 628 variable on the PlayStation side. And so we're conditionally setting this 630, and so because we don't have the right symbol names, we have to. I'm going to do that just as a placeholder. Maybe not the best placeholder. We have to just see how the symbols are being used, and what may be happening is this is being assigned and then unconditionally. Nope. Let's look at what that looks like from the decompiler. I see. There's it's doing a comparison against these two values. So let me back that out. Just looking for which one is the greater of the two. Or, sorry, the lesser of the two, it looks like. Hey, Highlander 71. No, I've never played it. Isn't my understanding is that the GameCube version is some maybe descendant of that version of the game, because I think that was on the Triforce hardware. When I get back over to the PlayStation side, bring this back over, I will check these symbols and see which ones are correct. $73. Still seeing some issues. Okay, so I was doing so in one case the assignment's not happening, but we are taking the value. And where is this being used again? Yeah, it looks like AX was the arcade version, and then GX was the home version. And was there some like Neo Geo style, like home and arcade interaction that you could do, or was that something else? I thought there was something like that as well. Like, I don't know if games ever had like GameCube memory slots, like they did have Neo Geo memory card slots. Oh, really? So that is crazy. In the 90s, of course, I would have never been able to afford a Neo Geo. And I don't know that I ever saw a Neo Geo cab that had a memory card slot in it. And now that seems like incredible that something like that existed. I'm going to go back here one more time and oh, actually, yeah, this will be a separate variable. And we can use just about any of the ones that exist already. So I'm just going to throw this in X. And see how this goes. We might have to change the variable later, but Oops, wrong way. Yeah. The Highlander, your comment got flagged because of the F. Sorry, just find it amusing. Yes, the F, the F0. Apparently, I thought you gave 0 the Fs. Yeah, they have. All right. Oh, let's see. We need a little bit down here on line 188. Okay, so this is what prompted me to come get the PSP version to begin with. So we're going to branch if equal to 1. And, sorry, or less than, no, I guess it's equal to 2. So we're just checking directly whether this value is equal to 1 or 2. That was much simpler than I was making out to be. Well, I don't know if I know any synonyms for potato that would be flaggable. But that's maybe I need to learn something today. Down on line 118, this params is not a separate variable. Yeah, feel free, proceed. I'll unblock it if it gets flagged. Unless it's I guess unless it's that flaggable. All right, so one of the things that I did up here, I okay, so if that's a thing, that's not a potato, I don't know what it is, and I don't think I'm going to look it up. How about that? I'm happy with my naivety. Is there a there isn't a big potato item in Soten, right? There is in Bloodstained. I'm pretty sure in Bloodstained there is a baked potato item. So there are register differences here, and we're missing a variable. I'm going to go back here and give this a new variable. I'll just call it temp. And I think this will basically then be matching on the PSP, give or take a few registers. Oh no, that wasn't enough. Instruction-wise, everything looks good. Just some register mismatch, and this S1 and S0 I would have to go back through and see where those diverge. It may actually be so up on line 27, that's just a temporary variable. I can't do anything about that. Occasionally reordering these will make this work. I'm not, since the PlayStation is, or the PSP is not our target, primary target, I'm not going to focus on that right now. But I'm going to take this back over and see if this is a match. And it looks like it is. So the last thing that I'm going to do, now I have to worry about the one variable that, the one global that was the wrong type, because I won't be able to integrate this back in, having the symbol defined two different ways. What I want to do is check to see whether the immediate values that are different are significant in any way. And if they are, then I need to fix them. The first one I see here is this 18FFE8. That is these. So it looks like the order is wrong. Symbol variables I'm not worried about, unless it's something like this where we have those symbols defined for this function and they are the wrong symbol. So I have to come up here, and line 69 is where this is failing. So I'm loading 24. And that's going to break for different reasons, so let's see what's going on here. It could just be that these two lines are out of order, because they're doing the same. Oh, they're doing the same thing. No. Is it possible that these are being assigned to each other? That wouldn't make sense. So there is an issue here that will need to be taken care of. And really, it just looks like these are happening out of order. But it's not letting me correct that. So I'm going to continue on. Let me try moving this down below. This order seemed correct on the PSP side. So there may be something else going on that needs to be resolved. Actually, this A1, A2 is a good hint that something is amiss. So let's swap these. Possibly need to no, I'm not sure what might be causing that. It is possible that this is a vector positioned at offset 24. We can try that. I think it's worth trying. And then 2.8 and 2C are both not going to be a thing, and that's going to screw up whether we're matching over here or not. Just really in the symbols, though. It would be nice to see this working. so they're still out of order. If I switch their order, does that help? Oh no, something else has gone wrong. I missed one somewhere. Might as well just do a global replace. All right, so let's see if that. Oh yeah, that a lot of work to get a much worse match. So let's back all that out. Okay, so something is happening which is resulting in the ordering of these two assignments to be flipped. There's a couple things that we can do to attempt to force the ordering. Wrapping these in a do while seems to convince GCC that the ordering here is important, but it also may affect the cache, and it looks like it is affecting this cache. We can actually probably move the assignment out of that do while loop. This is that one weird GCC trick. Apparently not in this version of GCC though. No, yeah. More recent versions of GCC allow you to do that. We could just throw the do while empty one right in the middle. And that might act as a barrier. This has happened. No, that's broken too. This has happened in other places. Kind of a bummer that this is where it's gonna. This might be where it ends today. Everything else looks great. So if I was going to take this now, the way we would normally integrate this into the project is to find where we're currently including. Sorry, what was the news? 6674. Oh, wrong one. We use this include ASM macro to include assembly that's been extracted from the game. These are functions that haven't been decompiled yet. And I would just paste in my function here. And like I said, there's going to be some cases where there are variables that have different declarations already. So I'm going to see a few things that are missing. These are because my context in my local project is different from what's here. So I'll have to resolve these before being able to integrate this in correctly. But it looks like it's pretty close. Currently, this is building what we're building now, and where this function will live is TT004, which is the sword familiar overlay. I will spend a little bit of time after the stream and try to work out what the deal with that ordering problem is and get my context updated so that I can integrate this more easily. So we have been decompiling the sword familiar for Castlevania Symphony of the Night. Normally I would stop now, but what I want to do is let's go to DuckStation and play the game a little bit and see where this function gets invoked. So the way that I do that is I'm going to take the address of this function. When they're extracted from the overlays, we get the address in memory where they're going to be loaded, and that's used as the name of the function, splat, which is the utility that we use for separating all the parts out, is what does that. I'm going to add a breakpoint, execution breakpoint, for that address. And then we will get going. Hopefully my controller is set up now. And let's turn on the sword familiar. Oh, do I not have it in this? I loaded the wrong save. Let me try my other save. This may be better. Oh, there we go. So now when this function gets called, we should see that breakpoint get hit. Let me make sure that breakpoint is still in place. That's what it is. And in other cases, we've seen like sword attack, for example, trigger, like when the sword has decided what it's going to attack, we trigger a particular function. In this case, though, this doesn't look like it is getting triggered yet. Let me disable the sword familiar and see if that triggers it. Okay, so this looks like potentially this is something. Oh no, never mind. I was going to say this may be something related to tearing down the sword familiar. But what has happened is I've left my breakpoint in, and this same overlay is in the same memory space for the fairy, and so not sure what function this is, but we're going to hit the same memory address for the fairy. And so when I switched to fairy, that was probably a mistake, because we're going to hit that same function there. So what to do? Really, how I would proceed now is continue to play through, trying to trigger this function. I may go back to the main game engine and see where this particular function is being invoked, and possibly it's there's some other scenario that I'm missing. I'll try to look into that as well, and maybe we can come back and see where these are. There's a bunch of these functions that they don't have names yet. For none of the familiars do we have a good sense of what those functions are primarily for, and so we have to come back and name them eventually. So we have been working on decompiling Castlevania Symphony of the Night, specifically the sword familiar. If you're not familiar with that project, you can go to soten.z.dev, and I'll find it eventually. You'll find the overlays that we've been working on and what the progress is for those. We've been working today on the sword familiar. I really need to get the code. I have maybe 5 or 6 functions now that haven't been sent out for PR. So quite a bit more of the sword familiar is done than what's seen here. I just haven't sent them back out yet. So as we get further along, I'd say we're maybe between 20 and 25% through overlays. There's still a ton of stage overlays to work on. So the project has quite a bit more work to be done. We're building tooling and other things like that, though, to find duplicate code and help get things into a decompiled state more quickly. And every week, things go quicker and quicker. So if you're interested in the project, stop by soten.z.dev. You'll find a link to GitHub. You'll find a link to Discord. If you want to decompile, you're interested in reverse engineering or any of those things, PlayStation, MIPS, stop by and say hi. Other than that, I will be back tomorrow, and we'll see if this function can get integrated. That's all I have. Bye.